Ever wonder why the smartest AI systems on the planet still confidently make up completely fake information? Today, we are cracking the code on why language models hallucinate, and the answer is surprisingly human.
It really is a fascinating parallel.
Well, welcome to our podcast, Artificial Intelligence, Papers and Concepts, curated by Dr. Sakya Malik.
And before we really get going, we should probably mention that both of the voices you are hearing today,
Oh yeah, mine and yours.
right, mine and yours, are entirely AI-generated voices.
Which is pretty fitting given the deep dive we have planned for you today.
Yeah, we are looking at a really incredible paper from September 2025 titled Why Language Models Hallucinate.
And this research comes from an absolute powerhouse team. You've got Adam Tamankalai and Ofer Netcham from OpenAI.
Along with Santosh Esvampala from Georgia Tech and Edwin Zhang, who is also at OpenAI.
So the mission for this deep dive, for you listening, is to unpack the rigorous statistical logic and the socio-technical pressures that cause these models to just fabricate information.
Right, showing that hallucinations aren't some mysterious ghost in the machine. They are mathematically mandated errors driven by how we train and test these systems.
Okay, let's unpack this. Because the analogy the researchers use right at the beginning is just so relatable.
I mean, yeah, they say you have to look at language models like a student taking a really hard exam.
A student who is, heavily incentivized to guess instead of just admitting they don't know the answer.
Exactly. And that pressure to guess leads to these highly plausible but totally incorrect statements. The researchers actually proved this using one of the paper's own authors.
Oh, right, the birthday example.
Yeah, they asked the state-of-the-art model, specifically DeepSeek v3, for Adam Tamankalai's birthday. And the prompt explicitly instructed the AI to reply only if the answer was actually known.
Only if it actually knew it, and it failed 3 separate times.
It did. Instead of abstaining, it output 3 completely different fabricated dates: 0307, 1506, and 0101.
And his actual birthday is in the autumn, so it just entirely hallucinated those.
It gets even clearer when they asked about his PhD dissertation title. They ran this on ChatGPT, DeepSeek, and Llama.
And all of them completely hallucinated, very believable, but totally fake academic titles, right?
Yep. ChatGPT gave them boosting, online algorithms, and other topics in machine learning. DeepSeek made up a Harvard paper. Llama made up an MIT paper.
They sound incredibly real.
They do, but they are just highly probable amalgamations of his research domains. The model is guessing brilliantly, but failing completely at factual retrieval.
It is wild how confident they sound while being completely wrong. We're going to dive into the mathematical proofs that actually guarantee these kinds of errors right after a quick word.
Sounds good.
This podcast is sponsored by BigVision.ai, a consulting and product development company that helps companies of all sizes build computer vision and AI solutions. You can reach them at contact@bigvision.ai.
Right, so getting back into it, we need to look at why this happens on a structural level.
Yes, because a lot of people just assume hallucinations are a symptom of dirty training data.
Right, but the paper argues that even with a completely flawless, error-free data set, the AI would still hallucinate.
What's fascinating here is the rigorous mathematical boundary they establish between generative tasks and binary classification.
Oh, wait, let me jump in. I think you mean the IIV problem.
Yes, the is it valid binary classification problem.
Right. What's fascinating here is how they mathematically prove that generating a valid output from scratch is inherently harder than just answering the question, is this valid?
It makes sense intuitively. It's the difference between verifying a solution and actually finding the solution yourself.
Exactly. And the paper proves that a generative error rate is mathematically bound to be at least twice the IAV misclassification rate.
So even if your pre-training data is perfect, the standard objective of minimizing cross-entropy loss naturally forces the model to generate errors.
Because it distributes probability mass smoothly across a wide array of tokens, it mathematically has to assign fractional probabilities to incorrect tokens.
Which guarantees errors when you sample from it. And that brings up the singleton rate, which I love because of the historical connection.
The Alan-Turing connection.
Yeah, Turing and I.J. Good's missing mass estimator from their World War II Enigma code breaking.
The concept is brilliant. Basically, if a fact like a specific birthday or a local election result appears exactly once in the training data,
A singleton.
right, a singleton, then models are mathematically expected to hallucinate it. The optimization process just doesn't allow the network to firmly retain a concept it only saw a single time in trillions of tokens.
Here's where it gets really interesting, though, because it isn't just about probability math. Sometimes it is quite literally a poor model problem.
Yeah, structural limitations. They illustrate this with the classic trigram model.
A model that only predicts the next word based on the previous two words.
So if the prompt is, she lost it and was completely out of, the model only sees the words out of.
It has no idea the sentence started with shoe.
Exactly. So it faces a 50-50 coin toss between saying her mind or his mind. It just lacks the structural context.
And we see a modern version of this with tokenization, the DeepSeek counting example.
Yes. They asked a standard frontier model, how many Ds are in DeepSeek?
And it hallucinates the answer, saying 2 or 3, because it processes text in aggregated token chunks, not individual letters.
Well, when they asked the DeepSeek R1 reasoning model, it got it perfectly right.
Because the reasoning model spells it out step by step in its chain of thought. First letter D, count as 1, second letter E, and so on.
It bypasses the token bottleneck, proving that sometimes hallucinations happen simply because you're using the wrong architecture for the query.
The researchers also touch on computational hardness. Like if you ask a model to guess the decryption of a secure encryption key,
It is forced to output random hallucinated garbage because the math is simply intractable.
and of course G.I. Joe, garbage in, garbage out. If there are contradictions in the training data, the model will output contradictions.
So that is the pre-training side. We know the models are mathematically forced to guess and smooth over data.
But the industry knows this. That's why we have the whole post-training alignment phase, to teach the AI to be honest and say, I don't know.
Right, but it's failing. And if we connect this to the bigger picture, we find what the researchers call a socio-technical epidemic.
The leaderboards.
The leaderboards. Almost all primary AI evaluations use a strict binary 0 to 1 grading rubric.
We're talking about GPQA, MMLU Pro, SWE Bench, Humanities Last Exam.
All of them. They give 1 point for a right answer and 0 points for a wrong answer.
Or, and this is the kicker, 0 points for an I don't know.
Exactly. It is an epidemic of penalizing uncertainty. Just like a human taking a test without a guessing penalty, the mathematically optimal strategy for the AI is to always bluff.
Never say I don't know, because a random guess gives you a fractional expected value greater than 0.
Abstaining guarantees a 0, so a perfectly honest AI that abstains when it's unsure will physically score lower on these leaderboards than a reckless AI that just blindly guesses.
We are actively selecting for overconfident, hallucinating models.
This raises an important question. How do we actually fix the leaderboards without overhauling the entire industry?
We have to add explicit confidence targets to the test instructions.
Which is such an elegant solution. The paper suggests appending a strict mathematical rule to the prompt.
Like saying, answer only if you are strictly greater than 50% confident, since mistakes are penalized 1 point, correct answers receive 1 point, and I don't know receives 0.
Which is exactly how traditional standardized tests used to work.
The old SATs.
Yes, or the AMC math tests. By adding a fractional penalty for guessing, you force the model to weigh its internal confidence before committing.
It completely flips the expected value calculation. Now, it is mathematically optimal to abstain. They call this behavioral calibration.
Right, because instead of forcing the model to spit out a weird raw probability like, I am 0.27 confident,
Which feels so unnatural in a conversation.
it just behaves reliably. It provides a useful answer if it clears the threshold, or it executes a clean abstention if it doesn't.
So what does this all mean?
Well, it means hallucinations aren't a bug.
Exactly. For you listening, the big takeaway is that until the industry stops grading AI like a standardized test that rewards bluffing, we will continue to get AI that acts like an overconfident test taker.
We have to start measuring and rewarding when an AI successfully abstains, not just when it gets lucky on a wild guess.
Knowing what you don't know is crucial.
Mm-hmm.
And I want to leave you with one final kind of provocative thought as we wrap up.
Let's hear it.
Throughout this deep dive, we've been talking about text generation, answering trivia on academic benchmarks.
Right.
But we are rapidly moving toward agentic AI. We are connecting these models to systems where they execute code or process real financial transactions.
Oh, wow. Yeah.
If our grading systems are forcing AI to be a reckless test taker in text, what happens when it operates as an autonomous agent?
A wrong guess isn't just a drop point on a leaderboard anymore.
It's a real-world action with actual consequences. If we don't fix this epidemic of penalizing uncertainty right now, we are essentially handing the keys to autonomous systems that fundamentally believe it is mathematically optimal to confidently crash the car rather than admit they don't know the route.
That's definitely something the industry needs to solve immediately.
Absolutely. Well, thank you so much for joining us for this deep dive into the source material. We loved unpacking the rigorous math and the socio-technical realities of this paper with
It
you.
was a fantastic discussion.
If you found this breakdown valuable and want to keep exploring the complexities of the latest AI research, please make sure to subscribe to the show. We will catch you on the next one.